Hello, Algebra 1 students. This is lesson 43. Our objective is how do you simplify rational expressions? And before we go too far, let's make sure that we understand something. If you have something like this, 2 times 3 divided by 2, well, 2 times 3 is 6. 6 divided by 2 is 3. Right? That reduces down. Or if you said 2 times 3 over 2, you could reduce those 2's and end up with just 1 times 3, or 3. Sometimes we call that canceling. Okay? But please know that you can only do that if everything up here is multiplying. If everything up here is multiplying. For instance, if you had this, where you had 2 plus 3 over 2. 2 plus 3 is 5. 5 over 2 is 2.5. This is the correct answer. You cannot do this where you just reduce the 2's and be like, oh, I'll cancel those out and just give me 3. That is not good. So don't ever do that. I'm just going to cover this up before you look at this too much. Maybe get the second in your brain. No, don't do that. Do this here on the left, okay? If they're multiplying, then you can reduce them. Otherwise, no. Good. So let's just remember something real quick. If you have 0 cookies and you want to share it amongst your 5 friends, notice that each person would get 0. It's a little bit of a silly question, but it does make sense, right? That each of your 5 friends would get no cookies because you have no cookies to share. Okay? What does not make sense is if you have 5 cookies and you're going to share it amongst 0 friends. Well, what? You mean, like, why would you even ask that question if you don't have any friends to share it with? Why are you trying to share cookies if you don't have anything to share it with? It just doesn't make any sense. Okay? So this is undefined, and there's more mathematical reasons besides it just doesn't make sense. But just for now, you cannot have 0 on the denominator. It makes it undefined. We use this symbol, which is the empty set symbol, or we call it the undefined symbol. Okay, so you cannot divide by 0. Anytime you divide by 0, makes it undefined. Makes the expression undefined. Okay, and that's what we're going to be doing here in example 1, is determine the value or the values of the variable that make the expression undefined. So pretty much we're saying what x cannot equal. So really what we're looking at is when does this denominator equal 0. So that's what I'm going to solve. I'm going to say 3x is equal to 0. To solve that for x, I'm going to divide by 3. And I just end up with x is equal to 0. Okay? So then, for this would make it undefined. So for this, I would say x cannot equal to 0. Okay? On this next one here, again, I'm going to say, when does this denominator equal to 0? Because I don't know what x cannot equal. So when does x minus 7 equal to 0? Well, to solve that, I would add 7 to both sides. End up with x is equal to 7. So then, x cannot equal to 7. And one more. Again, we're looking for when does this equal to 0. So when does 5x minus 15 equal to 0? Well, I'd add 15. I get 5x is equal to 15. Divided by 5 to get the x by itself. End up with x is equal to 15 over 5 is 3. So that would make it undefined, so that means x cannot equal to 3. Alright, now we're doing 2 things here in this example 2. It says simplify each expression, rational expression, and then determine undefined values. So that determine undefined values is the part where we just did in example 1, except for first we're going to try to simplify first. So let's see about factoring. Let's look up here at the top for a second. What number could I factor out of both of those? Well, 9 factors out of both of them, so I could say that this would be 9. 9 times 3 gives me that 27, and with the x would make it 27x, and then plus 1, because 9 times 1 gives me 9. And then my denominator would be x minus 10. So now I'm looking, is there anything I can maybe reduce from the top and the bottom? Well, there's no x minus 10 up top, so I cannot reduce anything, and this doesn't factor out. So this is going to just stay like this. So the last thing I have to do is figure out where does x minus 10 equal to 0. Solving this, I get when x is equal to 10. So then I'm going to say x cannot equal to 10. And this whole thing here is going to be my answer. Okay, let's try the same thing here on part B. Again, I'm going to see what I can factor out of both terms there on the top. Well, I see that I can factor out a 4 and an x from both of those on top. So it's going to be a 2x left over, and then minus 1. On the denominator, I see that I could factor out a 4 and an x. That's going to leave me with 3x plus 2. Now we notice that there is something from the top and the bottom, and since this is multiplying by that, and this is multiplying by that, I can reduce these. Okay. So those 4's are reduced to 1, those x's reduced to 1, and I end up with just 2x minus 1 over 3x plus 2. And I need to see, when does 3x plus 2 equal to 0? It's going to be 3x equal to negative 2, or x is equal to negative 2/3. But we also have this piece right here that we ended up reducing down, that 4x. When does 4x equal to 0? If we divide both sides by 4, x is equal to 0. So then I'll put a comma and say x cannot equal negative 2/3 or 0. And that is my answer there. Let's try one more here. What can I factor out of the numerator there? I see a 7 and an x I can factor out. It's going to give me an x plus 3. On my denominator, I see that I can factor out a 5 out of both of those. End up with an x plus 3 left over. So notice, now I have this times this times this, and this piece is the same on both of them. So I can reduce the x plus 3, and I end up with 7x over 5. Well, when does that denominator equal 0? That's whenever x plus 3 is equal to 0. 5 doesn't ever equal 0, right? So we don't have to worry about that one. So if I subtract 3 from both sides, I get x is equal to negative 3. So then x cannot equal negative 3. Alright, your homework is there on page 272. You're going to do the lesson practice, all the 43s, all the 42s, and 3 more of your choice.